My name's Aaron Friedman. I am a principal solutions architect here at AWS. Been here about 3.5 years, working with our healthcare and life sciences partners, so our ISVs and systems integrators, helping them build solutions on behalf of our collective customers. And today, we're in the Global Partner Summit, GPSTEC341, and we'll be talking about how we can build solutions to get insights into patient health, focusing a bit on Amazon Comprehend Medical, which is a service that we launched last year at re:Invent. This is a 300-level session, so we'll be presenting some architectures, walking through a bit of code. We're not going to get into the really deep guts of the service, but hopefully at the end of this session, you'll be able to sort of understand where this service can help, right, in terms of different business outcomes that could be meaningful to either yourselves or to your customers, as well as just start to think through overall architectures and how we can sort of advance patient health together. So when we talk with our customers and our partners, these are some of the common questions we ask, and my guess is, because this is a healthcare session, some of you may hear the same things, be focused on the same things. Questions around the lines of, is my treatment that I'm delivering actually properly tailored to the patient, right? We hear about adverse drug events. If you're an oncologist, the reality is a lot of the drugs that get prescribed to a patient don't work. So how can we advance precision medicine? Along the lines with adverse drug events, is my treatment safe, right? We did a workshop yesterday on how we could very simply look at some reviews and start to cluster drugs based on adverse events. Can I get a better patient view? We talk a lot about things like patient 360, patient centricity, the digital front door. But really, how can I better understand what is going on with my patient now, as well as in their history and in the context of their entire population? And because we're talking about healthcare, how do I actually protect this data? How do I make sure that this very personal information about my patient population remains secure? And we'll talk through some of the architectures today that can enable this. But really what underlies a lot of these is this idea of how do we identify the right treatment for the right time for the right individual based on their longitudinal history as well as the broader population. And I always think about it, if you're in the US and you look on the back of your coin, you see this e pluribus unum, out of many one. So really, how do we use the broadest set of information to deliver personalized care to individuals when they need it? And one of the key challenges that we've heard from customers is around the lines of, if I'm in the medical record or I have adverse drug event reports or radiologist reports, there's a lot of unstructured data in these reports that have extreme value if I'm able to properly extract that. Now you can do this manually, right? You can have clinically trained annotators or people that are walking through and extracting meaningful information from unstructured text, say in a health record, a SOAP note, etc., and sort of ascribe meaning and structure to that. But to do this at scale is incredibly challenging. It's exhaustingly time intensive. So how do we actually scale and untrap all this clinical data? And we heard a lot from customers that it's really difficult to extract insights. And because most of our roadmap is very much customer and partner driven, we built this service called Amazon Comprehend Medical, which we launched sort of under our Comprehend umbrella. And you can think of Comprehend Medical as sort of a medical language processing or medical NLP service. So what it does is it gives you a couple different APIs that you can interact with. The first one is what we call our NERE API, so it's named entity and relationship extraction. And what this does is it can identify different types of entities, things like medication, medical condition, test treatments and procedures, anatomy, and sensitive health data like PHI. But that's valuable, but you can get a lot of that from bag of words and fuzzy matching. The really key thing here is you get relationships between the entities, which gives you a lot more value in terms of how you actually structure this information. So things like medication and test and result and dosage are really important. And not just that, you need to know, for example, negation, right? The classic example I give, right, is patient takes 81 milligrams of aspirin daily is different than patient is not, or patient went off of taking this, right? And that contextual information is really important. And the only way, really to do this at scale and to do it well is to develop, models now built on deep learning and best practices with NLP to extract as much valuable information as possible and to do so correctly. So before we dive into the architecture, let's just quickly take a look at what it looks like. Hey, it's reInvent. It's near the end of the week. Vegas is dry. I had a headache. My vitals are normal. They said, hey, give me acetaminophen. Just obviously mock-up. And this is what it looks like in the code, right? So it's very simple. You interact with this purely over API. You pass in a body of text, and you get a response back. So I may say, using Bodo 3, this is what it would look like in Python. And then I'd get a set of a JSON document with a set of entities and relationships between those entities back. And you can see the visual representation at the top where it's not just the entities you're getting back, but a test value about my vitals or a dosage response to acetaminophen. So you're able to get contextual information, not just about the entities themselves, but actually, what the dosage is, et cetera. So there's a lot of value in here, and this, again, is simple synchronous API. You submit the data, you get it back very, very quickly. And you can imagine as you're building applications, now all of a sudden I have this unstructured text that a doctor may have written down, or maybe it was transcribed. I'm really excited that we launched Transcribe Medical this week because there's a really natural plug-in with a lot of this, from dictation to actual extraction. So there's it gives you a really nice sort of near real-time pipeline to get valuable information out of unstructured text. And our partners in the last year have been innovating. This is a partner summit, so talks. I'd be remiss if I didn't talk about some of the brief work that our partners are doing. So if you look at what they're tackling, ClearData, for example, is actually using this service as part of their new ClearData Locate tool, which actually does distributed tracing over a Kubernetes environment and can track, for example, where PHI flows in your environment. And partners like Deloitte and PwC are looking at using this service for things like real-world evidence and pharmacovigilance. So there's a really broad set of use cases, whether you're in life sciences or healthcare, that are valuable. But all of it gets back to really how can we get more information about our population and do so in a way that is automated and scalable and less expensive than if we were to have to do it manually. So with that out of the way, this is a very high-level architecture diagram of what we're going to talk about today, right? So if you think about what a lot of people are building now, population health analytics, et cetera, a lot of it is how do we actually build the right, for example, machine learning models that can predict better patient care, engage with our patients better, bring the right innovations, for example, maybe to tackle adherence, which is a multiple hundreds of billions of dollar problem alone in the US. But that's sort of that end state. There's a lot that we need to do up front to actually get the data in a format in a way that can become actionable. So what we're going to talk about today is really this early stage, right? How do we ingest more streaming data feeds, if you will, into the platform? How do we look at batch uploads? And then how do we actually normalize and secure that data so that when we are ready to build our algorithms or make inferences from our data sets, we're able to do so in a way that better enhances our patients. So let's start with interoperability. Interoperability is a huge challenge across any industry. And the reality is it can be hard. We have multiple data standards. Data historically in healthcare has resided in silos. Now this is changing with broader sets of regulations around data sharing and and meaningful use, et cetera. But the reality is there are legacy protocols, poor communication, multiple standards. So actually integrating and normalizing those data up front is challenging, right? So if we look at how the community's evolved, historically with healthcare messaging, there have been things like HL7 and HL7 V2, which is a pipe-delimited format that delivers sort of messages and information. That has since really evolved into FHIR, Fast Healthcare Interoperability Resource, which is a new and emerging standard, and it's, I think now in revision 4. But the idea here is, can we take the information, for example, that was in JSON and actually structure it in a way that is RESTful, that we can actually interact with programmatically using protocols like HTTPS. DICOM, outside of that, is a imaging standard, right? If we think about what the two of the biggest data producers in the hospitals are, it's our electronic health records, or that operating system of the hospital. But a lot of information is trapped in those medical images, those imaging modalities. So DICOM is sort of a standard, right, which sits on top of different sort of PACS or medical imaging vendors, and allows for interoperable data sharing. And then if you want to really contextualize information to an individual, maybe you're doing something by looking at their genomic profile, right? So variant call file is something that has come up in the last 20 years or so since genomics has been around. But it's a way of describing differences of a person's genetic variation compared to a reference population. And these are only some of the data standards, right? We have a broad set from reimbursement, et cetera. So the reality is we need to have a way that we can easily synergize these data. And if we start by just looking, and we're not going to go into all the standards today, but if we take a look at the text, right, the healthcare messages standards, a lot of that is with HL7 and sort of the more legacy systems, and the emerging standard FHIR. So in the past, we've done a lot of work in terms of helping our customers and partners build interoperability solutions. We have a wide variety of partners as well that enable interoperability, partners like Redox and InterSystems and Rhapsody, et cetera. But the general idea here is you ingest these messages based on the best way to do so for the individual protocols. So you may have some gateway that's accepting HL7 and lands it in a document repository in S3. Similarly, you may have built an API gateway that can accept FHIR messages and take sort of those FHIR endpoints. You parse the data with and validate the JSON using AWS Lambda. You may store some of that data or metadata in Amazon S3, but then you're also storing the raw files storing the metadata in DynamoDB and the raw files in S3. I don't know how many people here have worked with FHIR or HL7, but there's unstructured text there. So even if you're storing the data, there's value up front that if we index the data on ingest, we can further gain insight into what's going on with our patients. So one way to evolve this is to actually then, once you're storing the data, say FHIR or HL7, have a secondary process, right, that maps takes the FHIR resources, extracts out the unstructured text. So FHIR, you may see that in a narrative field within one of your resources, pipes that unstructured text through Comprehend Medical, you get that JSON back, and then you can further enrich your data sets. Maybe you're mapping them to an ontology like SNOMED, and then you can store it back, whether it's in S3, maybe you have a separate API that processes that data that you just enriched. But the general idea here is you can overlay Comprehend Medical onto an existing architecture and get further meaning from your data. And what this looks like is, we have a blog here, so please feel free to take a picture. These slides will also be published after the fact. But the general idea here is if you take this, I believe it was an MDM message, an example from that, and you see sort of the clinical summary based on the information provided, the patient likely has viral sinusitis, commonly called a head cold. Well, there's information there, and yes, in this case, sometimes bag of words could work. But if we take Comprehend Medical, right, and we extract the information from here, all of a sudden now, you can see that, hey, we're getting a JSON document back that's talking about medical condition. We have anatomy as well, so a head cold. And then what's not shown here, but what was done in the blog, is you actually then can map it to the SNOMED API, or call the SNOMED API, say with the browser, et cetera, or if you have an ontology yourself that you're mapping to, and further enrich your data set. So if you look here on the right, you actually see head cold and the code that's, for example, that's mentioned for it from SNOMED. So these are, again, the types of things that you can do with real-time data feeds. And the value here is because we're doing this up front, we don't have to do it again, right? As we then go downstream and look at, say, feature selection or selecting the right parameters, or maybe you're doing not even feature selection for machine learning, but you're trying to do just basic ad hoc queries to understand your patient population. Having this structured data and not having to do, say, like clauses and things like that within your SQL queries, this can be quite valuable in terms of continuing to structure that data up front. So if we now take a pause, this is sort of where we're at, right? We have our ingests sort of from our real-time or near real-time data feeds. They can go through API gateway. You can have some type of, you can land them directly in S3. And then you can have pipelines that do post-processing, say adding and enriching that original data. So let's go to the bottom right now and talk about batch. The reality is, right, if we started this today, and obviously that'd be great, but if we started this today, we have a whole set of legacy information that we need to figure out and deal with. So that could be pulling in from the EHR, that could be health records that, you know, honestly from a personal experience, having moved in the last couple of years, doctors actually still mail health records. It's fascinating that this is still the case. So digitization of and batch upload of health records to fully understand a patient's longitudinal profile is still something that we have to do today. So let's take a look at that and see what an architecture might look like. So SFTP is still a protocol that is widely used, and you're encrypting, right, everything in transit. So you're maybe taking PDFs that have been scanned of documents and pulling that data in. Again, that would land in Amazon S3. That's a very common architectural pattern here, right? We're not covering things like metadata management with regards to a data lake and how you're tracking and tracing that governance as part of the talk, but you'd imagine that would probably be part of this as well. And then you can have either automatic triggers or perhaps some type of CloudWatch event that is basically acts like a cron job and pulls in all that new data that perhaps you uploaded in the last day and do some pre-processing and post-processing of that data. So you can imagine at a high level what this might look like is you upload the data to S3, and now you have a simple workflow that orchestrates these processing steps. So you can imagine if we're, say, uploading PDFs, again, something that has happened to me in the last couple of years, you could pre-process that data, and perhaps you're calling Amazon Textract, which is our OCR-like machine learning AI service that can pull out information within tables and text within documents, et cetera, and keep them organized. And then from there, you can pipe, again, that text through Comprehend Medical, right? So if my document had, you know, simple things like my name, et cetera, okay, but then if there's a longer note about some type of care, that could then be piped through Comprehend Medical. And then you could post-process and organize it, whether you're moving that data to a database, collecting the files, creating new resources from that data. Perhaps you're post-processing into a FHIR resource or a set of resources and loading that data back into S3. But you can do all this orchestration as well using step functions, which the team's actually been iterating quite a bit, but you can think about this as really a state machine, right? We're passing pointers, we're passing information between states, and it's a way to sort of overall orchestrate the entire framework. And with this as well, the other thing that you might do in here is if we are doing batch uploads, each of these individual Lambda functions may be something where we're actually doing a batch process. Maybe we're running multiple tech extract jobs because we've uploaded a lot of data into our platform in the last day. And then we want to do batch for Comprehend Medical, and then we want to do all of our post-processing together. And this is something we heard a lot from customers about, right? Because the reality is we have prospective, everything that's coming forward, but we need to collect and analyze all this data from the past. So one of the things that we launched in the last year was Batch, and being able to process these data at Batch. So again, this is something like everything in AWS, really. You can interact with it, of course, via the API. This is what it might look like, right, where you basically upload all your files that you want to detect entities from into an S3 key space, right? So you imagine key prefix as well as the input bucket where your data resides. You have your outputs as well. And also, right, you define simple things. You always, this is health data, so we should always encrypt our data, right? So a KMS key yarn that you own, the language code, which right now Comprehend Medical only supports English. But this on the right is a very simple thing of what it actually looks like in the console, again, so you can visualize. You have the ability to call both APIs, whether it's detect entities or detect PHI. So if you wanted to run a batch data protection type process and identify where PHI may sit in your environment. I know other companies I've talked to do things like risk profiling of their overall set of data. So you can, again, look at where PHI actually resides and build that inventory and then operate on it as you might need within your organization's requirements. So again, you can do all of this in batch. And this ends up being quite valuable because now instead of interacting with the API synchronously, you interact asynchronously, you submit a job, and obviously you wait for it to be done. But what happens behind the scenes is we scale up in sort of a parallelized fashion, and we run each of the pieces, the bodies of text through our model, and then we output it, and you get sort of an individual input to output as well as an overall manifest of all the data that you provide. So there's again a lot of value here, and you can encapsulate all of that into that Lambda function where you're submitting the job, and then you do something like maybe a long poll, which is a very common architectural pattern that we've seen both for this as well for other services in the past, say with combining step functions in AWS Batch before that native sync command came out. So now we've gone through streaming data, batch. The big challenge is how do we actually normalize it, right? So, true story, when I was writing this slide, I was like, okay, I'm going to talk about acetaminophen and Tylenol to start, and I spelled acetaminophen wrong. And the reality is when we go to different care providers, et cetera, or if someone's producing a name brand drug versus not, normalizing data and mapping back to ontologies is something that's really important. So when we look at this, these all should be the same thing, right? If I misspell something, or I have a name brand drug, ibuprofen, Advil, Motrin, Nuprin, et cetera, or different medical condition, myocardial infarction versus heart attack, we want to make sure that we're collecting that data and presenting sort of a unified ontology for whether it's a medication, a medical condition, et cetera. And this really gets to the fact that this is critical in healthcare, and we have done as an industry a lot of work to solve this, or to get towards solving this. So there are different ontologies, right? RX norm, looking at different sort of prescriptions. So Vyvanse, for example, maps to an RX norm code. ICD-10 for reimbursement, right? I've also seen cases where ICD-10 codes are actually used for phenome-wide association studies mapping back to genomics. And then SNOMED is another really common one, right? Where fingers might map to hand and finger. But the reality is, again, to actually properly contextualize this, you not only need the entities and map the entities back, you need to have the relationship between those entities as well. So if you take the ICD-10 example here, right, we don't want just tenderness or left hand. We want pain in the left-hand fingers, right? Which we get from tenderness, we get from fingers, and we get from left hand, right? So there's combining the relationships between entities is really important. And our team recently published a paper in Archive, if you're familiar with Archive, ARXIV, around how this might look and some of the ways that they're thinking about it. And the reality is rule-based systems don't work as well. They can get by in a lot of cases, but ideally, because you need that deeper contextual information, not just about the entity, but what surrounds it, deep learning-based approaches are really quite valuable here. So the way that they're sort of thinking about it, just giving some insight, and this is all public. Please feel free to read the paper itself. If you search LATTE on Archive, that's the acronym that they've described. But the general idea is you get a text, which is a description of the context. You can pipe that through Comprehend Medical. You get the entities and the relationships between those entities. You sort of do, you can do things like fuzzy search for candidate generation, mapping back to an individual ontology. And then you can use deep learning-based models to actually rank the individual concepts. And you can take the top one if you want, for example, and use that as your, for example, ICD-10 code if you want to do things like computer-assisted coding and get out sort of the manual nature of things. So that covers batch. That covers normalization. Let's take a quick look at data protection, right? So now if we think about, we've got our real-time or near real-time feeds, we've uploaded, we have a general idea now of how we can start to think about normalization of that data. So if we start to look at security, this is something that's really important. And I obviously put this out here separate, but the reality is security can and should be built into every part of your application. So what we'll talk about next really could be embedded at each layer, right? And the general idea here is if we're doing things like population health, et cetera, a lot of times we don't need all the sensitive information about an individual. In some cases that may help in terms of broader aspects of social determinants of health, but a lot of the identifiers say in Safe Harbor we don't need to necessarily keep into our overall, say, data platform that we're then training models on. So we can do things like data masking, et cetera, up front or post-process at the end. It really depends, again, on your pipelines, et cetera, and how you make those decisions. So this was something that we were talking a lot right after the service announced. And at the beginning, I think I actually failed to mention, we have two APIs, right? So we have the Detect Entities API, and we have the Detect PHI API. And the reason we split those apart and they're different pricing is a lot of customers came to us at the beta and shortly after launch as well and said, look, we want to know where the sensitive information is. Like that's table stakes for us. We haven't had the visibility into that. We'd like to work on that. So and this really gets back to masking and protecting data helps reduce risk in your organization. You know, regardless of you have a specific security compliance regimen that your organization needs to follow, whether it's internal or industry-wide, protecting data should be critical, right? We at AWS always talk about security being job zero, and a lot of that not just into our overall architecture, things like identity access management, et cetera, but actually into things like encryption and data masking to make sure that only authorized individuals can actually access the data that they need. And this, at a high level, gets into two steps, right? You need to identify where the sensitive information lies in your environment, and then you need to figure out actually how to mask and identify it. And these are really two discrete steps. So you can think of this almost, again, like a state machine. You can orchestrate it separately, say, with something simple like this with AWS step functions. But you don't necessarily have to. You can sort of bake in your organization's processes as well. But the general idea here is you can identify PHI, and you can do so with your organization's existing methods complemented, for example, by Comprehend Medical. And then you operate on whatever type of data that you have as you need it. For example, maybe you're doing something like, I don't know, just say very simply, replacing all potential sensitive data with pound signs, right? So there's no way of masking it back. One other way, for example, is looking at things where you're actually, say, to improve readability for an individual, you do things like, hey, replacing the name, so replacing Aaron Friedman with the attribute. So Aaron Friedman becomes name, my age or date of birth becomes date of birth, and things along those lines. You may want to generate tokens or hashes that also represent your data. Perhaps you're storing it in a separate place to enable re-identification as you need it, based on, again, on identity access management and permissions for specific individuals. So there's a lot of flexibility here, and the secondary piece of data masking is often something that maybe your GRC within your organization has already established, right? So the general idea here, though, is Comprehend Medical can help augment your existing processes with the first step in data protection, which is that critical identification piece. You can't protect what you can't identify. So we worked with actually several customers on this at the beginning of the year and throughout the year, and what we've done since then is we actually released what's called an AWS solution. So AWS solutions are, you can think of them as deployments. They go into your own AWS account, but they're designed to actually solve some type of basic business outcome that you can take and modify as needed within your organization. It's all open source. You can go review the code. But we released one, and we did a couple builder sessions the last couple of days at reInvent here on this as well, around using this type of framework for masking data, right? So if you go back and you think about the fact, when I was talking a little bit about interoperability, that two of the big pieces that we have to work with in the healthcare industry are medical images and medical text. How do we actually start to rationalize that and protect that data? So we released this targeting these types of things sort of as an example API that you can use based off of some work that we did with customers as well as our own thoughts internally. But the general idea here is I can identify images, say, or I can identify text and images using a service like Amazon Recognition. They have a detect text API as part of it. You can then take that text, pipe it in Comprehend Medical, identify where some sensitive data may exist and PHI may exist within that environment. And then you could just do, again, mask it however your organization likes. You can draw bounding boxes over it. You can do a bunch of different things. But your output then is a masked image. And similarly, you can do this with text, right? The general idea here is if I pipe my name through it in a string, it would return back my name with the example. And in this case, we used AWS Lambda, and we just sort of built in sort of all that code with a common shared library to just reduce the overall dependencies and not use step functions as well. I included this because it's a nice sort of visualization. This is something that you can go and deploy and play around with yourselves as well. Comprehend Medical does have a free tier, so please feel free to take a look. But this is something that deploys in your account in a couple minutes, and you can sort of test, modify as needed, and all the source code is available as well on GitHub. No faces or anything like that as part of this. This is all using Recognition's Detect Text API, right? Which is separate from everything else. And really just looking at the overall text redaction and using that as a data feed into Comprehend Medical for this. Again, similarly, you can imagine that, let's say now, and we haven't added this yet because, hey, it was announced this week, if you're using Transcribe Medical, and a doctor's dictating notes, and they may say something that's actually sensitive and shouldn't be exposed outward to someone, you're able to take a transcription of the doctor's message, pipe this through a similar type solution like this, and immediately mask your data. So it's immediately covered before you even get any further. So there's a lot of utility and stuff around this. And the way that we built this was actually using sort of a shared library. Lambda has layers. It's often a good architectural practice. But we just sort of built this into our overall CI/CD pipeline where we had sort of common libraries that we used, or common functions. And this is some of how it looks, right? So we're just abstracting away the API calls in this case, where if we take, how do we actually in this example solution, how do we mask text? This is the actual code that you could find on GitHub. So the general idea is, first thing we need to do is extract PHI from text. Comprehend Medical returns not just an identification of where data may reside, but also a detection threshold or a confidence score. So you can filter as, again, based on the needs of your organization. But if you want to be overly sensitive, you could set it to 0, so it captures everything. And in this case, we're just calling the detect PHI API, and we just filter by threshold, so we can return that. And you have the ability to sort of specify that. That would then get fed into sort of the second function here, and that's sort of what you actually see in the Lambda function itself if you go in there. But the general idea is we have a list of entities. In this case, that would be that array that's returned from the top. And then for each one, we're replacing the text that was identified by its type. So that way you can sort of still be able to read it, understand where names are, where dates of birth are, addresses are, et cetera. So this is sort of how it works on the back end. So now we're here, right? And the general idea, and we're not going to get into deep learning today, and this is sort of the last little bit, but now if we take a step back and we look at where we're at, right? So we've thought about how do we take more real-time or near real-time data feeds, things like FHIR, HL7, any other type of message that you would need, be able to store it in S3, and then sort of, again, augment those original data messages using a pipeline to store the data and metadata and enrich with Comprehend Medical. We've looked a little bit, again, similarly on how do we tackle batch, both from the Comprehend Medical API standpoint, but if we think about a very common use case, which is the digitization of healthcare records, how that could look layered on, say, with Amazon Textract, right? And then normalization, how do we actually map that to a ontology? How do we start to think about how do we take misspellings, different names, et cetera, and understand how to link it back to an ontology of interest, whether that's ArcsNorm or SNOMED or any other type of thing. And really the value there is not just the entities that you identify, but the contextual information that surrounds each individual entity. And then lastly, with this bit of data protection, right? So how do we identify PHI, for example, in our environment and do things like masking? Now, the last little bit, of course, you could bake into each of these ingest pieces as well. It would probably be an architectural practice that I would recommend. Again, so you're not doing the same thing multiple times. But now what we have is we have a way of taking unstructured text, whether it's from batch or from more streaming near real-time data, and structuring it and protecting it on ingest. Because what this now gets you is the ability to do really cool things, say with SageMaker or other, whatever your sort of machine learning platform is of choice, and being able to not only use the information from the structured data fields you got in, but the unstructured data as well. So with that, I do want to close. We have several, these are a few of many related sessions as well. Some of these have already, I know, happened. I'll have my email up on the next slide. Happy to connect you so you can see the materials for the workshops. We talked yesterday about how to cluster adverse events with Comprehend Medical and SageMaker. Yesterday as well, there was sort of that architecture I described around streaming messages with FHIR and overall interoperability. We talked about that yesterday in a workshop, HLC401. And there's a broad set of healthcare sessions that are applicable as well, clinical applications on AWS, et cetera, as well as a set of different blogs and everything like that. So if you look at the second one, for example, that's that FHIR Comprehend Medical integration that I described with that screenshot. There's a bunch of different sort of tools. If you search our blogs as well as our AWS samples GitHub repos, there will be several things that come out. So lastly, I want to close and I want to say thank you. Not just for coming to the session, but for being here at reInvent. It's an incredible opportunity to learn, and it's a blessing from my side to get to work with all of you. You know, for me, being able to work at a company and help and work with others to advance patient care is an incredible mission. So this is my email. Please feel free to use it. Happy to connect you with service teams, work with you on your problem challenges that you're facing as organizations, or connect you with others who are well equipped to do so as well. Again, thank you so much. We have about 20 minutes, so I'll stay just outside for any questions. But with that, again, thank you and have a great rest of your reInvent.